Okay, so this is section 2.5, transformations. What we're going to be learning today is how to move a graph left, right, up, down, how to reflect it, how to shift it, how to expand it. So, as you do this, this is a little bit of review from last year, but as you have questions, please come up here and just kind of list your questions so we can talk about them in class tomorrow. Okay, let's consider the function f of x equals root x. So first things first, let's graph it on this first set of axes here. Let's plug in some points. So if I say the square root of 0, hopefully you're all saying 0. Square root of 1, again, 1. Hopefully we're all saying 1. Square root of 4, we're saying 2. That's a little off, but let's say that's 2. Square root of 9, hopefully we're thinking 3. So root x would be something along these lines. Okay, and it goes forever to the right to infinity, and you won't have any negatives because then you're in the imaginaries. Alright, now let's consider the next function, root x plus 1. What this means is you're taking that whole function and you're adding 1 to all the y values, which means we're going to be moving the whole blue graph up 1. Okay, so let's take all those blue points. If I take the point that was at 0, 0, I'm moving it up 1. The point that was at 4, 2 is now up at 4, 3. And 9, 3 is now at 9, 4. Again, that's a little bit funny, but let's sketch that in right there. Okay, so when you have a number that's separate from the function, so root x and then a plus 1 completely separate, now we're going up or down. All right, now let's take a look at the next one. So now I'm taking, whoops, there we go, root x plus 1 all under the radical. Now this one, it's a little bit different. It might be opposite from what you think, but if you remember, this one is actually left 1. So if I look at my original blue graph of root x, now I'm going to take all those points, so at 0, 0 is now negative 1, 0. What was originally at 4, 2 is now at 3, 2. 9, 3 is now at 8, 3. And now I'm looking like this. Now we'll talk a lot more later on about the domain and the range of everything. But for now, there's some left and right and up and down. Okay, so now take a look. Now what if we consider multiplying it by 2? That means I'm going to take the whole function root x and multiply all of the y values by 2. Now this one's going to be a little bit harder to see. So let's go a little bit smaller on the pen. So, root x, originally 0, 0. 0 times 2, no problem. Keep it at 0. Let's make it a little bigger. Okay, now the point that was at 4, 2, that y-coordinate of 2 gets multiplied by 2. Now I'm at 4, 4. Alright, that 9, 3 is now at 9, 6. So you can see this, what we call a vertical stretch by 2. Alright, so a number in front of the root x is going to multiply all of the y values by 2. Now, one of the trickiest functions, when you multiply the x's by 2 under the root, it's the opposite of what you would think. Just like if you look up here, see this left and green up here? When you see a plus 1, you think right, but it's the opposite. Same thing here. You see 2 times x, it's opposite. We're actually going to take half of all the x values. Now it's a little bit hard to see, but if I take the blue value, half of 0 stays put. But half of the 4, 2 point becomes 2, 2. And half of 9, about 4.5, 3. Okay. All right. Now a brand new function over here, a negative in front of the function. A negative in front of the function, negative in front of y, in other words, actually means I'm going to reflect it over the x-axis. So if I take my original function, all of the points are going over the x-axis. So now here's my function. Okay, so now if we look at the next page here. Now let's take a look at what happens with a root underneath the radical. Okay, so if the x's are negative, that actually means it's going to be a y-axis reflection. And that goes back to all the symmetry we've learned. If you want to check for y-axis symmetry, you make the x's negative. X-axis symmetry, make the y's negative. So it all kind of comes together here. So if my original function, rough sketch now, here's my original root x. If I want to go over the y-axis, all the points are now going to reflect, do these a little more carefully, over here. So here's over the y-axis. All right? Okay, let's take a look at another one. Absolute value x. This one's a little bit tougher. So this means all my positive values of x, so here's all my positive values, those are all perfectly fine. Now, when I start plugging in my negative x's, they are going to act like the positive x's. Okay, so consider this. A negative 4 on the x-axis is going to act like positive 4. Well, here's where positive 4 is. So a negative 4 is going to act just like the positive 4. And then a negative 9, so negative 9 acts like positive 9. Here's positive 9. Negative 9 acts like positive 9. So you have this double blue. So for instance, if you look back here at the previous example, the left side is the answer. This is not the answer. Whereas in the blue one, the left and the right is the final answer. Okay, one more example before we do a couple combinations. All right, now, I have a half times my x values. Again, you're doing the opposite of what you think. So instead of taking half of the x's, we're actually going to double the x's. All right, so 0, 0 stays put. What was originally at 4, 2 is now at 8, 2. And what was originally at 9, 3 is now way out here, somewhere where 18 is, at 18, 3. All right, so we did a little bit of one thing, one thing, one thing. Now, this level of pre-calc, you probably have already guessed, is not going to be one thing, one thing, one thing anymore. Now, let's try a couple more difficult ones. All right, so doing this, I want to first, on this axis, get regular old root x in there. Okay, so here's my red. It's the same function we've been dealing with. Here's root x. Okay, now I want to do one thing at a time, and I'm going to try to color code these so you can kind of see what in the world's going on. The negative in front, that's going to go over the x-axis. And I'm going to do that first. Whoops, axis. Okay, so if I take the red, excuse me, and I go over the x-axis, this is what I'm talking about. And I'm going to label that. Okay, now let's take over the x-axis and let's multiply the y values by 2. Alright, so all this green business, all the y values are going to be doubled. Alright, so take a look at the blue one. Negative 2 root x. Okay, now lastly, let's grab one more color here. Yellow. This x minus 1, that means right 1. Alright, so all the blue business, now I'm going to take all of the blue, and it's going to bump right 1. So, okay, now the hardest part about reflections is when you have a negative by your x's, that means a y-axis reflection, and a horizontal movement. When you have those two things together, it's really important to do the y-axis reflection first, then move it left or right. If you do those in the incorrect order, your graph is going to be kind of way out of whack. Okay, so let's get that function back on there. The same function over and over to get used to it. There's root x. Now, if I take that over the y-axis, now it's looking like this. Alright, and then if I take that guy and move it right 1, now it looks like this yellow again. So again, really important. Do the y-axis reflection, then the horizontal movement. Okay, now if you take a look at the next one over, it's kind of a tricky one because it's in a weird format. In math, typically, we like our x's first. But in order to do that, we need to take a negative out of all this. So now it looks like the previous example. So do me a favor, take a second and see if you can graph this new one. And then again, we'll go over this one in class so you can make sure you have all the right answers.